Previously, in the previous video, we talked about changing analog system to digital system, and now I'm gonna introduce a list of stuff in terms of the inverse differential equation that we have said earlier. Alright, which may be fairly useful in terms of the conceptual understanding of acceleration, velocity, and position, or certain analog system that I would say. So, for example, I have a system like this. Okay, I will call this the position. Alright, or in other words, this can also be the angle if you're talking about torque. Or if you still remember, if a mass, for example, if a mass in the real world is moving, alright, in a certain rotation, is talking about torque. Summation of torque is equals to I theta double dot, which is the angular velocity. Angular acceleration, sorry. If the mass is moving in ways in these directions, alright, in straight ways, alright, straight path, talking about forces, or in other words, when there is no rotation, I don't know. Yeah, if there is no rotation on the mass itself, then we're talking about summation of force is equals to mass times the position or the acceleration. Mass times acceleration, I would say, not position. Position double dot. Okay. So therefore, this is what I write as xt and theta t. Alright, for the position and torque. You may say in terms of temperature, maybe in terms of other stuff. Sorry, I don't go into details about it because it's more complex. So therefore, I have x dot t over here. I have theta t over here. And therefore, I'm going to prove to you that this is it. Alright, so therefore the acceleration that goes through 1 over s will give you a velocity, and the velocity that goes through another 1 over s block diagram will give you the position and the torque. Not torque, but rather than I will call this angle. Alright, the angle. And how do we start? So for example, if I were to zoom in into this scenario, if I were to copy this and I were to paste, alright, I'm talking about the acceleration and the velocity portion. Alright, this is the acceleration, this is the velocity portion. Okay, and I'll just say that this is velocity s, I'll call this the acceleration s. Now, alright, vs over here is equals to as times 1 over s. Alright, so I can just say that is as 1 over s. Correct? Now I bring this s out. I would have s vs is equals to as. Okay? And then if you remember back to the previous video, alright, s ys is equals to y dot t. Correct? If it's s square ys, then it's y dot t. And therefore, if I have svs, which is similar to sys, just y and v are different only, okay, I can simply say that this is simply y dot, okay, v dot t, sorry, this is v dot t is equals to at. Okay, for example, how do we okay, anyway, ys is equals to y. Alright, I forget the first order also. Alright, if it's ys without any s, alright, then it's just equals to y, and therefore as is equals to, is similar to ys, just y and a are different. Alright, so ys is equals to y, or yt, sorry, and therefore as is simply equals to at. And that's the meaning of it, because velocity, if you differentiate one time, alright, velocity, if you differentiate one time, you will have acceleration. What am I writing? Yeah, and therefore this proves this thing, that this is acceleration, this is velocity. I'm just deriving it. Alright, and same goes for this portion over here. Alright, I'll leave you to write it out. Okay, I'll leave you to write it out. And therefore, if you're talking about theta and its acceleration and its angular velocity, these are all the same thing. So this concept is very powerful in relating to the differential equation, alright, in terms of acceleration, velocity and time, where it goes in terms of the differentiation part. Alright, so the differentiation part is mostly on all this, and therefore this is why I in the very first part of this video we said that differential equation gonna deal a lot with this one, because in the analog system is in terms of position, and the changes or the velocity of the position and the acceleration of the position is all in terms of analog, and you're gonna change all this thing in terms of digital, and in order to do that you're gonna model them, and modeling them is gonna use this type of stuffs. Alright, and this is the toolkit that you will be putting into your toolbox, and I shall see you soon in other videos. Goodbye.